Number 6, part A says state the limit definition of the derivative of f of x. So there are actually 2 correct answers we will accept here. So if you want to give the general form, which gives you all of the derivatives, we can say, well, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So this would actually give you, right, all possible derivatives. Right? So that's the general form. We would also accept f prime of a equals the limit as h goes to 0 of f of a plus h minus f of a all over h. So this would actually produce one specific number, which would be the derivative at x equals a. So this is the derivative at x equals a. So it's sort of like with an indefinite integral, we get an equation and we use the plus c because we're getting the general form. With a definite integral, we have bounds, right, and it actually produces a numerical solution. So either of these would be acceptable answers. B says use the limit definition to show that the derivative equals this. So we've actually given you the final answer, and it says you will receive 0 points for using the power rule because we actually want you to apply this definition. So since the final answer is in a form of a function of x, we need to use this definition. Now, I don't like to do a lot of algebra inside of a limit. I think it's cumbersome. You have to write limit over and over, and it really creates an opportunity to maybe mess up that limit notation. So one nice thing you can do is you can actually do some of the algebra up front before you build the limit, and then that way you're just evaluating the limit. So f of x plus h is going to be 12 times x plus h minus 2 times x plus h squared. So I'm actually going to expand and simplify this first before I go on and build my limit. So the 12 is going to distribute, and we're going to get 12x plus 12h. I'm going to leave the negative 2 alone for a second, and I need to FOIL out or expand x plus h squared. So that's x squared plus 2xh plus h squared. And then now I'm going to take this one step out further and distribute this negative 2 across. So negative 2x squared minus 4xh minus 2xh squared. My function f of x is just 12x minus 2x squared. So now I'm ready to build my limit. So f prime of x equals the limit as h goes to 0 of f of x plus h. So all of this stuff. And then I have to subtract the entire expression 12x minus 2x squared. So a really common mistake that students make on these problems is they'll forget to put this part of the expression in parentheses because that negative has to be distributed all the way across. So now when I look at this problem, hopefully if I've done all my algebra correctly up front, everything without an h in the numerator should cancel. So I have a 12x here and a negative 12x. Those actually add to 0. I have a negative 2x squared and a negative 2x squared, which is positive 2x squared. So those cancel. And all I'm left with is the limit as h goes to 0 of 12h, oops, forgot to cancel that, there we go, minus 4xh minus 2h squared all over h. Another common mistake that's made is people try to get a little overzealous when they're canceling the h's here. So I really, really do recommend, as a check for yourself, that if you try to cancel anything out of the numerator and the denominator, especially on these limit definition problems, factor the h out front. It's just better. So we get 12 minus 4x minus 2h all over h. So now I'm allowed to say the h in the denominator cancels the h in the numerator. Once that h in the denominator is gone, then you're ready to evaluate the limit of what's left. So this is 12 minus 4x minus 2h. This should be able to be done by direct substitution, and all you have left is 12 minus 4x as desired. So I find this to be a really, really helpful tool to just sort of build and do the algebra, as much of it as I can up front, so that way when I build the limit, I'm just now working with the limit steps. But otherwise, you would have had to write limit, 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 limit. You'd have these giant limits all the way down, and you can see on the written key that's what was done, and this is just an alternative way to approach the problem. Part C says we'll determine all the values for which the graph has a horizontal tangent line. So horizontal lines have a slope of 0. The tangent line, or the derivative, is the slope of the tangent line. So really what it's saying here is set f prime of x equal to 0. So our derivative from part B is 12 minus 4x. I'm going to set that equal to 0. This is the same thing as 12 equaling 4x. You add 4x to both sides, and when I divide both sides by 4, 3 equals x. And so all they wanted were the x values, so we can stop right there.